We are going to work through now the odd numbered problems from your core practice paper. So if you've already checked your answers and you're not sure why something didn't match up, this is the place to come. All right, in each one, we're going to start with our same template. Ending amount is starting amount times the multiplier to the power of t. Let's find the important information. So social media site is increasing its user base by 4.2% per month. If the site has 25,020 to start with, what will be the user base in 7 months? All right, let's fill in what we know. Don't know the ending amount. We do know the starting amount. We'll fill in the multiplier in a moment, and our amount of time is going to be 7 months. For the multiplier, always start with 100%. We are increasing by 4.2%. So that is 104.2%, which has a decimal. It's going to be 1.042. So let's pop this into our calculators. Now, this time we're talking about people, about users. So it's appropriate to use the whole number. So I'm going to call this 33,370. It would round down. So 33370. So there's about, I'm going to switch back to my blue. About, and so I'm using the just approximately symbol there, 33,370 users. Do put a unit on there, a label of what it is that we are measuring. And there it is. Next up, once again, let's set up our template to start with. Exponential change always looks like ending amount is starting amount times your multiplier to the power of t. Company promises to release a new smartphone model every month. Ooh, that is ambitious. Each model's battery life will be 4.2% longer. Okay, so we're talking again about an increase. Because with longer, that means the time is going to be bigger each time. If the current model's battery life is 684 minutes, what will the battery life be in 9 months? Okay, let's fill in what we know. I don't know the battery life in 9 months, but I do know the battery life now, 684.0 minutes. We'll look at the multiplier in just a moment. Our time is going to be 9 months. Now, this multiplier, because it's the same percentage as the previous one, we're going to end up with the same multiplier as the previous one. But just for practice, this gives us 104.2%, which has a decimal, 1.042. And when I get my final answer, I'm going to round it to the nearest tenth because the starting value was rounded to the nearest tenth of a minute. So 684, 1.042. And that is to the power of 9. Always make sure you get that time up in the exponent for your exponential models. Okay, so I'm going to round this to the nearest tenth, so 990.5 minutes. Now, if you're not sure where to round, it's better to include too many decimal places than not enough. So if you don't know where to round it, just write down all the decimals that come out of the calculation. Next up, a robot vacuum, so like a Roomba, cleans the dirty floor using multiple passes. Now, what we're saying there is it's going over the same area more than once. So it's not the most efficient robotic vacuum, but so it goes over the same stretch of carpet, let's say, and or wood floor or whatever. And on the first pass, it picks up 22.7% of the dirt. Then it goes back over the exact same area and picks up another 22.7% and just keeps going back and forth over that same area. That's what we're talking about. So we got to change as a percent, so exponential model is appropriate. Multiplier to the power of t. We don't know how much dirt is left after the 8 passes. We do know some other things. So we remove, I'm going to switch to my yellow there. We remove that much dirt, so that is a decrease because we're removing the dirt, so the amount of dirt goes down. The floor initially had 450 milliliters. How much is left after the 8 passes? Okay, let's fill some things in. So starting amount, that's that 450 milliliters. The multiplier, we'll figure out here in just a moment. And the time measurement here is the number of passes. So that would be 8 passes up top. For our multiplier, always start with 100%. A decrease is going to be minus 22.7%. Let's see what that ends up being. And so leaves behind 77.3%, which as a decimal, always move it back 2 spots, 0.773. Okay, so let's now calculate out 450. So our starting amount times the multiplier. And it was, I want to check how many passes was it? 8 passes. So at the end, we're going to be left with 57.365. So I'm going to round that to 57.4. Since after the 3, we had a 6, which is closer to so 36 is closer to 40 than it is to 30. So I'm going to round it up to 57.4 milliliters. And I want that to be blue again for consistency. Now I rounded to the nearest tenth because the initial value had 1 decimal place. So I want my final answer to have 1 decimal place. And the unit of milliliters, I'm just double checking my number, because this original unit was milliliters. All right, very nice and good. Let's do this last one. So a country pledges to reduce its carbon dioxide emissions by 4.5% per year. Reduce, that means we're looking at a decrease. So if the emissions in 2022 are 7,660 MT, which is a metric megaton. All right, that's a lot. What are the maximum allowable emissions by the year 2032? We've got to do a little thinking this time. It didn't tell us exactly how many years had passed. We've got to think for ourselves. So from 2032 to 2022, how many years were there? Don't overthink it. It's a 10-year span. So the time we'll use this time is going to be that 10 years from start to end. So it took just that little bit of extra, but that wasn't so bad. Start with our model. Ending amount is starting amount times your multiplier to the power of t. Let's fill in what we know. I don't know the ending carbon emissions. I do know the starting carbon emissions. The multiplier will figure in just a moment, and it's going to happen over the course of 10 years. Starting with 100%, a decrease of 4.5%. That's going to leave us with 95.5%. And just a quick double check on that, because I did that calculation in my head, and even me, I sometimes make small, simple errors. So I'm going to do a double check. Sure enough, that looks good. So as a decimal, back 2 spots, 0.955. All right. Now this, notice, is rounded to the nearest whole, so we're going to round our answer to the nearest whole metric megaton. .955 to the power of 10. Okay, so 4833.5. So I'm going to round that up. 0.5 would round me up to 4834. So approximately 4,834 metric megatons. which I don't know, it still sounds like a lot to me, but I'm not a climate scientist. Okay, and all of these, I want you to see that it's really the same idea. Starting amount, multiplier, power, amount of time. And that multiplier tends to be the trickiest part. So just take a moment, make sure you know whether you're going up or down and by how much. And that sort of organization should help you get to the right place each time.